All right, number 8 is another one by elimination, and when you first look at it, you might notice that everything seems to be lined up. Not only that, everything kind of has the same number in front of it. So if you wanted to get rid of the x's here, you'd want to subtract. If you'd want to get rid of the y's, they're both -1, you'd also want to subtract. So either way, we're going to subtract here. So 6 minus 6 for the x's, they just go away. Now this one might be harder to see, but if you have -1 minus -1, that's what's going on here, this -1 minus -1y, that's really -1 plus 1. And those are opposites, so those go away also. So on the left side of this equal sign, we just have 0. And then 13 minus 9 is 4. So this is actually a really short problem. Since we got 0 equals 4, that means that there is no solution to this problem. When the variables both drop out, and you have a true statement, that means infinitely many solutions. But if the variables both drop out, and you have a false statement like this, 0 does not equal 4, that means there are no solutions. All right, and number 9, we have a word problem. And so for this word problem, the directions say, set up 2 equations and solve the system. What are the 2 numbers? Well, the first sentence says, a number equals another number times 3. So let's give those numbers variable names. So a number, I'll just call it x. You could call it whatever letter you wanted, equals another number. So a number besides x, I'll call it y, times 3. A number equals another number times 3. Great. So that is our first equation. I'm just going to write it down here. I'll change that to 3y instead of y times 3. All right, then we have another equation. 4 times the first number. Well, our first number was x, so 4 times the first number would be 4x. Plus 3 times the second number is 30. So we're just kind of translating word for word, number for number there. And now we have to decide how we're going to solve this. You could solve it either by elimination or by substitution. Either way will work. I would suggest that substitution might be the way to go here, because you already have one of the variables by itself. And so what we can do is plug this 3y into the other equation for x. And so what I would write is 4 parentheses 3y. So instead of x, I'm substituting in 3y. And then just complete that equation, plus 3y equals 30. All right, so back here, 4 times 3y is 12y. And 12y plus 13y makes 15y. So I'm just combining like terms. All right, 15 times what number equals 30? Or you could just divide by 15. 30 divided by 15, and you get y equals 2. All right, so of the two numbers, the second number, y, equals 2. And now you just got to plug that into one of the originals. I'll just plug it into this one here. X equals 3 times y. So x equals 6. Let's write that as an ordered pair. My numbers are 6 and 2. All right. And for the last problem, we have a graphing one. And the first equation is all set up, ready to be graphed. I'm going to graph it in red here. It's in y equals mx plus b form, where y is by itself. So you always start with the y-intercept, the number that's just by itself. In this case, that's positive 4. So on the y-axis, we're going to start at 1, 2, 3, 4 right here. And then the slope is -2, as in -2 over 1. That means I'm going to go down 2 over to the right 1. So down 2 to the right 1, Do that again, down 2 to the right 1. And I would just do that as many times as your graph allows, and then get out your straight edge to make the line. Now these are the ones where we have to kind of worry about, is it going to be a dotted line or a solid line? And it's going to be a solid line because this is an or equal to. So there's my line. And then we have to lightly shade either everything above it or everything below it. Since this is a less than sign, we're going to lightly shade everything below. So far, that's our answer. All of these ordered pairs, so far, solve this. All right, but we have the other one. And the other one is not set up to be graphed yet. We need to get the y by itself. So we'll subtract 3x from each side, making those x's go away. And then I still have negative y greater than or equal to. Now I have 6 and I have minus 3x. I like to put the x term first. That way it's in mx plus b form. Okay, but y is still not by itself yet because of this negative. So I need to divide everything by negative 1. So on the right side, I'm going to get positive 3x minus 6. Both of those just switched signs. Over here, y will be by itself, but then what you got to remember, this is an inequality. It's not an equal sign. So when you multiply or divide both sides by a negative, the sign reverses. So this used to be greater than, now it's going to be a less than or equal to. So this is what I need to graph. So I'll start down at negative 6, right there. And I'm going up 3 over 1. So slope of positive 3, up 3 over 1. Oh, you can see where they cross. And let's see here, a dotted or a solid line. Oh, this one is going to be solid also. So if it's one of these symbols, then you're going to have a solid line. If it's one of these symbols, you're going to have a dotted or dashed line. So this one's going to be another solid line. So there it is. And then which way are we shading here? Well, this is a less than sign, so we're going to need to shade everything lightly below that line. So it would look like this. Then here's the additional part. You need to figure out, okay, where are both of the shadings intersecting? And hopefully you can see it's right here. If you shade light enough, you can see this is the area where both of the shadings are together. And so we'll just darken that in. And what we're saying here when we darken this in is any of these ordered pairs will solve this system of inequalities. It will solve both of these at the same time. And since these are solid lines, that means any point that's right on the line will also solve these. If it were dotted, a point that was right on the dotted line would not be included in the shaded part, and that's why we would dot it to show that.